Thank you. So we've heard a lot of talks about different biological organisms. I'm going to talk to you about my research, which concerns an organism that's arguably smarter than all of those. At least it's an organism that has brains unlike bacteria. So in collaboration with an experimental group here at UAUC, we're tracking individual barcoded bees over extended periods of time. So honeybees are complex societies that form complex societies, and animals that form complex societies. And they show division of labor in which the worker bees that dominate the society, sorry, the worker bees that dominate the society, well, they have brains, and we're trying to understand how division of labor emerges among those workers. So we've been focusing on one particular interaction among these bees, which is the social interaction known as food exchange, prophylaxis. And it's known that this interaction doesn't simply happen because one bee is hungry and the other is being generous. It happens because they're actually communicating with each other. And so we have this data set lasting several days where we study these interactions. So in this next slide, I'm just going to give you a flavor of some of the results.
Yeah, that's cool.
You don't want to see the results.
Results at 2 grams.
Just keep that. You can just circle it 7 minutes.
Different program. Okay, there you go. So those are the results. So this slide is meant to just give you a flavor of some of the results that we've obtained from the data. So this first slide, I'm not going to tell you what these distributions actually are, but the point is that we're showing distributions for 5 different individuals chosen at random. And what you see is that these distributions are identical for each of the individuals. So it seems that, at least in terms of these particular distributions, workers are identical. There's no real differentiation among them, right? But if you look at the interaction profile of the colony as a whole, the second distribution shows you how much time different bees spend interacting with each other. And you see that this distribution is really, really long-tailed. So there are some bees that are really, really good friends and spend a lot of time communicating with each other. Others are mostly just acquaintances. We've also simulated spreading on the network to understand how things propagate on the network. And we found again that there's structure. The empirical network is a lot faster than a comparable reference model. Thank you.